Today's video is going to talk about the difference between empirical and molecular formulas. So we've mentioned before, when we started doing formula writing, that when we have a compound, for example C2H4, that we want to reduce it to its most simplified form. So we said that in this particular example, we could divide by 2 to end up with the compound C1, which we're not going to write the 1, and then H2. So in general, the empirical formula is the most reduced or the most simplified version of that formula. So let's say I asked you which of the following is an empirical formula: C2H2, C2H6, C4H8, or CH2. You have to look for one that cannot be reduced any further if it's going to represent the empirical formula, because that's the most reduced version. So if we look at C2H2, we could divide by 2 and reduce that out to CH. C2H6, we could divide by 2 and reduce it to CH3. C4H8 could become CH2. Only CH2 would be the empirical, meaning it can't be reduced any further. So then what's a molecular formula? A molecular formula is when you have a multiple of an empirical formula. So for example, if we have CH2 as the empirical formula, an example of a molecular formula could be any multiple of this. So we could do C2H4, we could do C3H6, C4H8. These would all be examples of possible molecular formulas for this empirical formula. The Regents also uses the word molecular to describe any time we have two nonmetals coming together. So C is a nonmetal and H is a nonmetal, so these form what we're going to talk about next unit, a covalent molecule. But for now, we just need to know that it's a multiple of the empirical formula. Additionally, since we're saying it could be any multiple of the empirical formula, you could even have CH2 as your empirical and molecular formula. It's a molecular formula because it consists of two nonmetals, and it's also an empirical formula because it can't be reduced any further. So here's an example. What's the empirical formula of a compound with the molecular formula C6H12O6, glucose? So we want to get the most reduced formula when they're asking for the empirical formula. So we're going to divide here by 6. And we get CH2O. Okay, so what we're going to do now is we're going to take our knowledge of empirical molecular formula and we're going to apply it to a question. So it says, what's the molecular formula of a compound that has an empirical formula of CH and a molecular formula of 26? So the empirical, remember, is the reduced one. The molecular is the one that's not reduced. So I usually remember like mommy is the bigger one. I don't know. Mommy begins with MO. Molecular begins with MO. If that helps you, great. If not, don't worry about it. So they're telling us the little one, which is CH. What we could do is we could find out how much that one weighs. So we look at our chemistry reference table, open up to your periodic table. Carbon weighs 12 and hydrogen weighs 1. So all together, CH weighs 13. And CH is the empirical one, the little one. The big one, the molecular one, weighs 26. So what we'll do is we'll take the larger one, divide by the smaller one to figure out how much bigger the larger one is. And it turns out it's 2 times bigger. So then what we do is we just multiply the little one by how many times bigger it is and distribute the values. So we end up with C2H2. So let's try another one. The empirical formula of a compound is CH2. The molecular mass is 70. What's the molecular formula? So again, they're asking us for what is the non-reduced version, the molecular meaning the larger one before it's reduced. So we know that the little one is CH2, or the empirical, the reduced one, is CH2. So carbon weighs 12, hydrogen weighs 1, and there are 2 of them. So altogether, CH2 weighs 14 grams. The molecular mass, which is the bigger compound, weighs 70. So what we could do is 70 divided by 14, which is 5. So that means that the molecular formula is 5 times bigger than the empirical formula. So we just multiply the empirical formula by 5, where you're distributing this in. So we end up with C5H10. Okay, so this one is just a little bit more complicated. Tells us the empirical formula is C3H4O3, and they tell us the molecular mass is 176. So C3H4 H4O3 is the empirical. First thing we have to do, like the ones that we've been doing so far, is find out what's the gram formula mass of the empirical formula. So that would be 12 times 3 plus 1 times 4 plus 16 times 3. This is equal to 88. Next, what we're going to do is find the molecular formula by taking the molecular mass, which is 176, and dividing it by the empirical mass, which is 88. And we get 2. So that means that the molecular formula is 2 times bigger than the empirical formula. So we had C3H4O3, and we're saying that the molecular formula is 2 times bigger. So we're going to distribute this across, and we get C6H8O6. So as far as your notes go, I would write down the steps that we just went through for determining what the molecular formula was. So we did first was finding the mass of the empirical formula, then dividing the bigger number over the smaller number as far as the masses go. So the mass of the molecular mass, what was given in the problem, and divide that by the empirical formula mass, the one you found out. And then with the answer we got, you distribute it across.